object in motion, it has some velocity and acceleration, which are vector quantities.
Children, welcome to today's lesson, Numerical Problems on Vectors. You must be wondering why we have to study numerical problems on vectors. Today, we shall find out all about numerical problems on vectors. How our requirements fulfill by studying numerical problems on vectors? All these questions and more will be answered in our topic for today, numerical problems on vectors. But first, let us share the learning objectives for today's lesson.
On completion of this topic, learners will be able to recall triangle law of vector addition, solve numerical problems on equations of motion.
Math and science were invented by humans to describe and understand the world around us. We observe that there are some quantities and processes in our world that depend on the direction in which they occur, and there are some quantities that do not depend on direction. Mathematicians and scientists call a quantity which depends on direction a vector quantity. A quantity which does not depend on direction is called a scalar quantity. A vector quantity has two characteristics, a magnitude and a direction. ਜਦੋਂ ਵੀ ਦੋ ਇੱਕੋ ਕਿਸਮ ਦੀਆਂ ਵੈਕਟਰ ਕੁਆਂਟੀਟੀਜ਼ ਦਾ ਕੰਪੈਰੀਜ਼ਨ ਕਰਨਾ ਹੋਵੇ ਤਾਂ ਤੁਹਾਨੂੰ ਉਹਨਾਂ ਦੀ ਮੈਗਨੀਟਿਊਡ ਅਤੇ ਡਾਇਰੈਕਸ਼ਨ ਦੋਹਾਂ ਨੂੰ ਕੰਪੇਅਰ ਕਰਨਾ ਪਵੇਗਾ। ਇਸ ਪਾਠ ਵਿੱਚ ਅਸੀਂ ਵੈਕਟਰਸ ਤੇ ਆਧਾਰਿਤ ਨਿਊਮੈਰੀਕਲ ਪ੍ਰੋਬਲਮਸ ਸੋਲਵ ਕਰਨਾ ਸਿੱਖਾਂਗੇ। ਵੈਕਟਰਸ ਨੂੰ ਅੰਕਾਂ ਉੱਤੇ ਐਰੋ ਦੇ ਨਿਸ਼ਾਨ ਲਾ ਕੇ ਦਰਸਾਇਆ ਜਾਂਦਾ ਹੈ। ਐਰੋ ਦੀ ਲੈਂਥ ਉਸ ਦੀ ਮੈਗਨੀਟਿਊਡ ਨੂੰ ਇੰਡੀਕੇਟ ਕਰਦੀ ਹੈ ਅਤੇ ਐਰੋ ਦੀ ਟਿਪ ਉਸ ਦੀ ਡਾਇਰੈਕਸ਼ਨ ਨੂੰ। ਵੈਕਟਰ ਦੇ ਇੱਕ ਅੱਖਰ ਤੇ ਲੇਬਲ ਲਗਾਇਆ ਜਾਂਦਾ ਹੈ ਜਿਸ ਉੱਤੇ ਇੱਕ ਲਾਈਨ ਲਗਾਈ ਜਾਂਦੀ ਹੈ ਤਾਂ ਜੋ ਉਸ ਨੂੰ ਸਕੇਲਰ ਰਾਸ਼ੀ ਤੋਂ ਡਿਫਰੈਂਸ਼ੀਏਟ ਕੀਤਾ ਜਾ ਸਕੇ। ਵੈਕਟਰ ਐਡੀਸ਼ਨ ਇਸ ਪਾਠ ਦਾ ਇੱਕ ਆਧਾਰਭੂਤ ਪੱਖ ਹੈ ਜਿਸ ਨੂੰ ਅਸੀਂ ਵਿਸਥਾਰ ਵਿੱਚ ਤਾਂ ਨਹੀਂ ਸਿੱਖ ਰਹੇ, ਪਰ ਇੱਥੇ ਅਸੀਂ ਵੈਕਟਰ ਐਡੀਸ਼ਨ ਨਾਲ ਸੰਬੰਧਿਤ ਨਿਯਮਾਂ ਨੂੰ ਦੁਹਰਾ ਰਹੇ ਹਾਂ ਕਿਉਂਕਿ ਇਹ ਵੈਕਟਰਸ ਦੀਆਂ ਨਿਊਮੈਰੀਕਲ ਪ੍ਰੋਬਲਮਸ ਦੇ ਅਧਿਐਨ ਲਈ ਜ਼ਰੂਰੀ ਹੈ। ਸੋ ਲੈਟਸ ਰੀਕਾਲ ਦ ਪੈਰਲੈਲੋਗ੍ਰਾਮ ਲਾਅ ਆਫ ਵੈਕਟਰ ਐਡੀਸ਼ਨ। ਵਿਦਿਆਰਥੀਓ, ਤੁਸਾਂ ਨੇ ਵੈਕਟਰ ਐਡੀਸ਼ਨ ਅਤੇ ਉਸ ਨਾਲ ਐਸੋਸੀਏਟਡ ਲਾਅਸ ਬਾਰੇ ਸਿੱਖਿਆ ਹੈ। ਹੁਣ ਇੱਥੇ ਤੁਸੀਂ ਪੈਰਲੈਲੋਗ੍ਰਾਮ ਲਾਅ ਆਫ ਵੈਕਟਰ ਐਡੀਸ਼ਨ ਨਾਲ ਐਸੋਸੀਏਟਡ ਲਾਅਸ ਬਾਰੇ ਪੜ੍ਹੋਗੇ। ਇਸ ਲਈ ਦ੍ਰਿਸ਼ ਚਿੱਤਰ ਨੂੰ ਧਿਆਨ ਨਾਲ ਵੇਖੋ।
Consider a parallelogram ABCD whose side AB and BC are represented by vector A and vector B respectively. Then the diagonal AC is represented by vector R is equal to vector A plus vector B, resultant of the vector A and vector B.
ਵਿਦਿਆਰਥੀਓ, ਤੁਸਾਂ ਨੇ ਪੈਰਲੈਲੋਗ੍ਰਾਮ ਦੇ ਡਾਇਗਨਲ ਨੂੰ ਦਰਸਾਉਂਦਾ ਵੈਕਟਰ ਰੂਪ ਵਿੱਚ ਰਿਜ਼ਲਟੈਂਟ ਪ੍ਰਾਪਤ ਕੀਤਾ ਹੈ। ਕੀ ਤੁਸੀਂ ਜਾਣਦੇ ਹੋ ਕਿ ਪੈਰਲੈਲੋਗ੍ਰਾਮ ਦੀਆਂ ਸਾਈਡਸ ਦੇ ਰਿਜ਼ਲਟੈਂਟ ਦਾ ਮੈਗਨੀਟਿਊਡ ਕੀ ਹੈ? ਇਸ ਕੁਐਸਚਨ ਦਾ ਆਨਸਰ ਲੈਣ ਲਈ ਆਓ ਵਿਜ਼ੂਅਲ ਨੂੰ ਧਿਆਨ ਨਾਲ ਵੇਖੀਏ।
Let's consider a parallelogram ABCD. If the angle between two vectors A and B representing the sides of the parallelogram is theta, then the magnitude of their resultant is given by R is equal to modulus of vector R, which is equal to under root A square plus B square plus 2AB cos theta. If diagonal of the parallelogram ABCD, say AC, makes an angle beta with respect to the side AB, then tan beta is equal to B sin theta whole divided by A plus B cos theta.
ਵਿਦਿਆਰਥੀਓ, ਤੁਸੀਂ ਵੈਕਟਰਸ ਤੇ ਕੀਤੀਆਂ ਕਿਰਿਆਵਾਂ ਨਾਲ ਐਸੋਸੀਏਟਡ ਲਾਅਸ ਬਾਰੇ ਕਾਫੀ ਕੁਝ ਸਿੱਖ ਲਿਆ ਹੈ। ਹੁਣ ਵਕਤ ਹੈ ਵੈਕਟਰ ਐਡੀਸ਼ਨ ਤੇ ਬੇਸਡ ਨਿਊਮੈਰੀਕਲ ਪ੍ਰੋਬਲਮਸ ਨੂੰ ਸੋਲਵ ਕਰਨ ਦਾ। ਸੋ ਆਓ ਪ੍ਰੋਬਲਮ ਅਤੇ ਉਹਨਾਂ ਦੇ ਸੋਲੂਸ਼ਨ ਵੇਖੀਏ। A particle has a displacement of 12 meter towards east and 5 meter towards the north and then 9 meter vertically upward. Find the magnitude of the sum of these displacements. Here there is a displacement of 12 meter towards east, 5 meter towards the north and then 9 meter vertically upward respectively. For finding the solution of the given problem, let us watch the visualization carefully.
Here, vector OA represents a displacement of 12 meter towards east. Vector AB represents a displacement of 5 meter towards north. And vector BC represents a displacement of 9 meter vertically upwards. According to polygon law of vector addition, vector OC represents the resultant displacement.
From the right angled triangle OAB, we get OB is equal to under root OA square plus AB square representing equation 1. Here OA is equal to 12 meter and AB is equal to 5 meter. On substituting the value of OA and AB in equation 1, we get OB is equal to under root 12 square plus 5 square. On simplification, we get OB is equal to under root 144 plus 25, which is equal to under root 169, which is equal to 13 meter. From the right angled triangle OBC, we get OC is equal to under root OB square plus BC square representing equation 2. Since OB is equal to 13 meter and BC is equal to 9 meter, on substituting the value of OB and BC in equation 2, we get OC is equal to under root 13 square plus 9 square. On simplification, we get OC is equal to under root 169 plus 81, which is equal to under root 250, which is equal to 15.81 meter. Hence, the magnitude of the sum of the given displacement is 15.81 meter. ਵਿਦਿਆਰਥੀਓ, ਡਿਸਪਲੇਸਮੈਂਟਸ ਹੱਲ ਕਰਨ ਵਾਲੀਆਂ ਪ੍ਰੋਬਲਮਸ ਨੂੰ ਹੱਲ ਕਰਨ ਉਪਰੰਤ ਆਓ ਕੁਝ ਅਜਿਹੀਆਂ ਪ੍ਰੋਬਲਮਸ ਨੂੰ ਸੋਲਵ ਕਰੀਏ ਜੋ ਕਿ ਵੈਕਟਰਸ ਦੇ ਸਮ ਅਤੇ ਡਿਫਰੈਂਸ ਨਾਲ ਸੰਬੰਧਿਤ ਹਨ। ਸੋ ਆਓ ਅਜਿਹੀਆਂ ਪ੍ਰੋਬਲਮਸ ਅਤੇ ਉਹਨਾਂ ਦੇ ਸੋਲੂਸ਼ਨਸ ਨੂੰ ਵੇਖੀਏ। If vector A is equal to 4i cap plus 5j cap plus 6k cap and vector B is equal to 7i cap plus 6j cap plus 9k cap, then find the length of vector A plus vector B and vector A minus vector B. Vector A is equal to 4i cap plus 5j cap plus 6k cap and vector B is equal to 7i cap plus 6j cap plus 9k cap. Now the sum of vector A and vector B is vector A plus vector B is equal to 4i cap plus 5j cap plus 6k cap plus 7i cap plus 6j cap plus 9k cap, which is equal to 11i cap plus 11j cap plus 15k cap. Therefore, the length of the sum of vector A and vector B is modulus of sum of vector A and vector B is equal to modulus of 11i cap plus 11j cap plus 15k cap, which is equal to under root 11 square plus 11 square plus 15 square. On simplification, we get modulus of sum of vector A and vector B is equal to under root 121 plus 121 plus 225, which is equal to under root 467, which is equal to 21.61. Now the difference of vector A and vector B is vector A minus vector B is equal to 4i cap plus 5j cap plus 6k cap minus 7i cap plus 6j cap plus 9k cap, which is equal to minus 3i cap minus j cap minus 3k cap. Now the length of difference of vector A and vector B is modulus of difference of vector A and vector B is equal to modulus of minus 3i cap minus j cap minus 3k cap, which is equal to under root minus 3 whole square plus into minus 1 whole square plus into minus 3 whole square. On simplification, we get modulus of difference of vector A and vector B is equal to under root 9 plus 1 plus 9, which is equal to under root 19, which is equal to 4.35. Let us solve another problem. Find a unit vector parallel to the resultant of the vectors vector A is equal to I cap plus 2j cap plus 3k cap and vector B is equal to I cap plus j cap plus 3k cap. Here vector A is equal to I cap plus 2j cap plus 3k cap and vector B is equal to I cap plus j cap plus 3k cap. Now the resultant of vector A and vector B is vector R is equal to vector A plus vector B is equal to I cap plus 2j cap plus 3k cap plus I cap plus j cap plus 3k cap, which is equal to 2i cap plus 3j cap plus 6k cap. Since the vector parallel to the resultant of the vector A and vector B is a unit vector parallel to its resultant, thus the unit vector parallel to the resultant is R cap is equal to vector R divided by modulus of vector R, representing equation 1. On substituting the value of vector R in equation 1, we get R cap is equal to 2i cap plus 3j cap plus 6k cap whole divided by modulus of 2i cap plus 3j cap plus 6k cap, which is equal to 2i cap plus 3j cap plus 6k cap whole divided by under root 2 square plus 3 square plus 6 square, which is equal to 2i cap plus 3j cap plus 6k cap whole divided by under root 49. On simplification, we get R cap is equal to 2i cap plus 3j cap plus 6k cap whole divided by 7, which is equal to 2 by 7 I cap plus 3 by 7 j cap plus 6 by 7 k cap, the required unit vector parallel to the resultant of the sum of the vectors. Let us solve another problem. Prove that when the angle between two vectors of equal magnitude is theta is equal to pi by 3, the magnitude of their resultant is equal to root 3 times the magnitude of either of them. Here the angle between the two vectors is theta is equal to pi by 3 and magnitude of vector A is equal to magnitude of vector B. Since magnitude of resultant of vector A and vector B is R is equal to modulus of vector R, which is equal to under root a square plus b square plus 2ab cos theta, representing equation 1. On substituting the value of theta and a is equal to b in equation 1, we get r is equal to under root a square plus a square plus 2a square into cos pi by 3, which is equal to under root 2a square plus 2a square into 1 by 2, which is equal to under root of 2a square plus a square. On simplification, we get r is equal to a root 3. Since magnitude of two vectors is equal, therefore the magnitude of their resultant is equal to root 3 times the magnitude of either of them. Let us solve another problem. Find the resultant of two forces. F1 is equal to 12 Newton due east and F2 is equal to 5 Newton due north. For finding the resultant of the two forces, let's watch the visualization carefully.
Let's consider a parallelogram OACB. Let F1 and F2 are the force acting along the sides OA and OB respectively of the parallelogram.
Here, the two forces are F1 is equal to 12 Newton due east and F2 is equal to 5 Newton due north. Since here the forces pointed in a direction such that the angle between them is theta is equal to pi by 2, since magnitude of resultant of these two forces is r is equal to modulus of vector r, which is equal to under root f1 square plus f2 square plus 2 f1 f2 cos theta, representing equation 1. On substituting the value of f1, f2 and the angle between them in equation 1, we get r is equal to under root 12 square plus 5 square plus 2 into 12 into 5 into cos pi by 2, which is equal to under root 144 plus 25 plus 0, which is equal to under root 169. On simplification, we get r is equal to 13 Newton, the required resultant of the two forces. ਵਿਦਿਆਰਥੀਓ, ਆਓ ਕੁਝ ਹੋਰ ਸਮੱਸਿਆਵਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ ਜਿਨ੍ਹਾਂ ਵਿੱਚ ਦੋ ਬਲਾਂ ਦੇ ਰਿਜ਼ਲਟੈਂਟ ਨੂੰ ਪ੍ਰਾਪਤ ਕਰਨਾ ਹੈ। ਸੋ ਆਓ ਅਜਿਹੀਆਂ ਸਮੱਸਿਆ ਤੇ ਉਸ ਦਾ ਹੱਲ ਵੇਖੀਏ। Two forces whose magnitude are at the ratio of 3:5 give a resultant of 35 Newton. If angle of inclination is theta is equal to 60 degree, find magnitude of each force. For finding the magnitude of each force, let's watch the visualization carefully.
Let's consider a parallelogram ABCD. Let F1 and F2 are the force acting along the sides AB and AD respectively of the parallelogram.
Let F1 is equal to 3x and F2 is equal to 5x are the forces acting along the two adjacent sides AB and AD respectively of a parallelogram. Here, theta is equal to 60 degree is the angle of inclination between two forces and modulus R is equal to 35 Newton is the resultant of the forces F1 and F2. Since magnitude of resultant of these two forces is R is equal to modulus of vector R, which is equal to under root F1 square plus F2 square plus 2 F1 F2 cos theta, representing equation 1. On substituting the value of F1, F2, theta and modulus R in equation 1, we get 35 is equal to under root 3x whole square plus 5x whole square plus 2 into 3x into 5x into cos 60 degree. On simplification, we get 35 is equal to under root 9x square plus 25x square plus 2 into 15x square into 1 by 2. The above equation implies 35 is equal to under root 34x square plus 15x square. On simplifying again the above equation, we get 35 is equal to 7x. On dividing both sides by 7, we get x is equal to 5. Now, the magnitude of the forces are obtained by substituting the value of x in the given forces. Thus, the required forces are F1 is equal to 3 into 5, which is equal to 15 Newton, and F2 is equal to 5 into 5, which is equal to 25 Newton. ਵਿਦਿਆਰਥੀਓ, ਆਓ ਕਿਸੇ ਐਸੀ ਪ੍ਰੋਬਲਮ ਨੂੰ ਸੋਲਵ ਕਰੀਏ ਜਿਸ ਵਿੱਚ ਰਿਜ਼ਲਟੈਂਟ ਦੀ ਮਾਤਰਾ ਅਤੇ ਦਿਸ਼ਾ ਦੋਹਾਂ ਨੂੰ ਪ੍ਰਾਪਤ ਕਰਨਾ ਹੈ। ਸੋ ਆਓ ਅਜਿਹੀ ਪ੍ਰੋਬਲਮ ਅਤੇ ਉਸ ਦਾ ਸੋਲੂਸ਼ਨ ਵੇਖੀਏ। Find the magnitude and direction of the resultant of the following forces impressed on a particle. Vector F1 is equal to 5 Newton due northeast. Vector F2 is equal to 13 Newton due southeast, and vector F3 is equal to 1 Newton due northwest. For finding the magnitude and direction of the resultant, let's watch the visualization carefully.
Let's consider a parallelogram OABC. Let F1, F2 and F3 are the force acting along the sides represented by the vectors OC, OD and OF respectively.
Let F1, F2 and F3 are the forces represented by the vectors vector OC, vector OD and vector OF respectively. Since the force F3 acts along a direction opposite to that of the force F2, therefore their resultant will be vector F is equal to vector F2 minus vector F3 representing equation 1. On substituting the value of F2 and F3 in equation 1, we get vector F is equal to 13 Newton minus 1 Newton, which is equal to 12 Newton, which will act along vector represented by vector OA. Now, the particle is under the action of the forces vector F1 is equal to 5 Newton due northeast and vector F is equal to 12 Newton due southeast. The angle between the forces F and F1 is theta is equal to 45 degree plus 45 degree is equal to 90 degree. Therefore, their resultant R is given by R is equal to under root F square plus F1 square representing equation 2. On substituting the value of F and F1 in equation 2, we get R is equal to under root 12 square plus 5 square, which is equal to under root 169, which is equal to 13 Newton. Suppose the resultant vector R makes an angle OAB is equal to beta with force F2, then tan beta is equal to F1 sin theta by F plus F1 cos theta representing equation 3. On substituting the value of F1 in equation 3, we get tan beta is equal to 5 into sin 90 degree by 12 plus 5 cos 90 degree, which is equal to 5 by 12, which is equal to 0.42. On simplification, we get beta is equal to tan inverse 0.42, which is equal to 22.7 degree. If the resultant is at angle alpha south of east, then alpha is equal to 45 degree minus beta, which is equal to 45 degree, minus 22.7 degree, which is equal to 22.3 degree. ਵਿਦਿਆਰਥੀਓ, ਆਓ ਕਿਸੇ ਐਸੀ ਪ੍ਰੋਬਲਮ ਨੂੰ ਸੋਲਵ ਕਰੀਏ ਜਿਸ ਵਿੱਚ ਰਿਜ਼ਲਟੈਂਟ ਦੀ ਡਾਇਰੈਕਸ਼ਨ ਨੂੰ ਪ੍ਰਾਪਤ ਕਰਨਾ ਹੈ। ਸੋ ਆਓ ਅਜਿਹੀ ਪ੍ਰੋਬਲਮ ਅਤੇ ਉਸ ਦਾ ਸੋਲੂਸ਼ਨ ਵੇਖੀਏ। On a certain day, rain was falling vertically with a speed of 30√3 meter per second. If wind starts blowing with a speed of 30 meter per second in the direction from north to south, find the direction in which a boy should hold his umbrella in order to protect himself from the rain. For finding the direction of the resultant, let's watch the visualization carefully.
Let's consider a parallelogram OACB. Let the velocity of the rain and velocity of the wind is represented by the sides OA and OB, respectively, of the parallelogram.
Here, velocity of the rain in the vertically downward direction is represented by vector VR is equal to 30√3 meter per second, and velocity of the wind in the horizontal direction from north to south is represented by vector VW is equal to 30 meter per second. The velocities vector VR and vector VW are represented by the vector OA and vector OB respectively. Let vector V along OC be the resultant velocity of the rain makes an angle theta with the vertical. Then tan theta is equal to AC by OA, representing equation 1. Since AC is equal to modulus of vector OB, which is equal to modulus of vector VW, which is equal to 30 meter per second, and OA is equal to modulus of vector VR, which is equal to 30√3 meter per second, on substituting the value of AC and OA in equation 1, we get tan theta is equal to 30 by 30√3, which is equal to 1 by √3. On simplification, we get theta is equal to tan inverse 1 by √3, which is equal to 30 degree. Hence, the direction in which a boy should hold his umbrella in order to protect himself from the rain is 30 degree with respect to vertical. ਵਿਦਿਆਰਥੀਓ, ਤੁਸਾਂ ਨੇ ਵੈਕਟਰਸ ਤੇ ਆਧਾਰਿਤ ਨਿਊਮੈਰੀਕਲ ਪ੍ਰੋਬਲਮਸ ਨੂੰ ਹੱਲ ਕਰ ਲਿਆ ਹੈ। ਆਓ ਹੁਣ ਤੱਕ ਅਸੀਂ ਜੋ ਕੁਝ ਸਿੱਖਿਆ ਹੈ ਉਸ ਦਾ ਸੰਖੇਪ ਕਰ ਲਈਏ। If the adjacent side of a parallelogram is represented by vector A and vector B respectively, then the diagonal of a parallelogram is the resultant of the vector A and vector B, and represented by vector R is equal to vector A plus vector B. If the angle between two vectors A and B representing the adjacent sides of the parallelogram is theta, then the magnitude of their resultant is given by R is equal to modulus of vector R, which is equal to under root A square plus B square plus 2AB cos theta. ਸੋ ਹੁਣ ਅਸੀਂ ਅੱਜ ਦੇ ਲੈਸਨ ਦੇ ਅੰਤ ਤੱਕ ਪੁੱਜ ਗਏ ਹਾਂ। ਹੁਣ ਤੁਹਾਡੇ ਲਈ ਇੱਕ ਟੈਸਟ ਹੈ ਜਿਸ ਨਾਲ ਪਤਾ ਲੱਗੇਗਾ ਕਿ ਤੁਸਾਂ ਨੇ ਕਿੰਨਾ ਕੁਝ ਗ੍ਰਹਿਣ ਕੀਤਾ ਹੈ। Let's start with this question. Consider two displacements, one of magnitude 5 meter and another of magnitude 12 meter. Find the angle between these two displacements so as to get a resultant displacement of magnitude 13 meter. Your answer should be theta is equal to 90 degree. Now let us see the next question. A body moves in such a way that it has displacement of 8 meter towards east, 6 meter towards the north, and then 4√6 meter vertically upwards. Find the magnitude of its resultant displacement. The answer will be 16 meter. Let's move to another question. A force of 15 Newton directed northwards to a force of 8 Newton directed westwards. Calculate the magnitude of the resultant. Your correct answer is 17 meter. Now let us see the next question. Resultant of two forces acting at right angles to each other is 2828 dyne. Find the magnitude of each force. Answer will be 2000 dyne. Let's move to another question. Two vectors of magnitude 8 and 6 are inclined to each other at 60 degree. Calculate the magnitude of the resultant. Your correct answer is 12.16. Now let us see the next question. Two forces whose magnitude are at the ratio of 6:10 give a resultant of 84 Newton. If angle of inclination is 60 degree, find magnitude of each force. Your correct answer is 36 Newton and 60 Newton. I am confident that you have all scored well. I hope you enjoyed the lesson as much as I did and are looking forward to the next class. Thank you for your attention and see you next time.